Okay, so here we have regular polygons. Okay, so all of these shapes, polygons, just have straight sides, closed edges, and the regular part simply means that all sides are the same length. Okay, so all of these are regular polygons, meaning this side is the same length as this one, which is the same length as this one. So essentially what you're going to be doing here is I want you to find the lines of reflection and degrees of rotation for polygons instead of quadrilaterals. So you've done the same thing. We've learned about lines of reflection. We've learned about points and degrees of rotation. Now we just need to figure it out for these shapes. So again, I want this to be through experimentation with the patty paper. So I'm going to go ahead and draw my triangle, and then I'm going to see, well, it seems pretty obvious to me if I go like so, that I'm going to see, oh, look at that, it perfectly landed right on top of itself there. Okay, so that would be a line of reflection. Now I want you to notice, because all the sides are the same length, what if here's my line of reflection that I've decided exists on my triangle, yes? What if I put the triangle like this, with the base here? So my base was there, but now I'm going to make this side my base. So see that? The base. Do you think that's still a line of reflection? Well, let's see. Let's fold along that line, and looky there, it's still matched up, but you see where it lies on the figure. So essentially it'll go there. Okay, now what if I put this and make it go up here? So if I go there, notice this line is now there. Is it still a line of reflection? Well, let's fold it over, and there it is. So do you see here that the triangle, we can, if we kind of rotate it and see now, if this is the bottom, we still have that line of reflection, and we tested it out. Something else we could do to see that maybe would be to like go and just leave it as it is, and notice it landed right on top of itself. Kind of hard to see because I made that really thick. So do you see how now we can do this again? Where's the edge? Right there. Okay. So in all those cases, I was able to get that triangle to land on top of itself. So we could even do that same thing. The square you should have from the last activity. So if you do, you're more than welcome to copy and transfer those notes over where we think those might be. So again, we're going to want to do the same thing. So here's a pentagon. That's a 5-sided shape. Okay. So again, I'm thinking that looks pretty good, just right down the middle there. So I'm going to test it, and notice since all of these sides are the same length, that side and that side are lining up exactly, which helps that they're all the same length. Okay, so see that we can kind of show there that this is going to land. If I just kind of flip that side up, it's going to land right on top. So again, I can go in and draw that line of reflection, and we might have the same thing here. What if I switch and make this line right here the bottom? So if I make that the bottom there, so interestingly enough, if this is my shape, see what happens when I fold it on top of itself. Did those corners match up in that line there? And it did. So we're going to want to draw that so it looked like it went from there to there. So see that from that corner to that side. So you're going to want to go through and find all the lines of reflection. We've got a hexagon, which is a 6-sided shape, an octagon, which is a 8-sided shape, and then this one is actually a nonagon, which is a 9-sided shape. So those will be the ones that you'll be required to find. Okay, then degrees of rotation. So here we go again. We're probably thinking it's going to be in the middle somewhere. Okay, so maybe right there where all those lines cross. So again, we need to find some degrees of rotation. So interestingly enough, I can find it there. Oh, my center was not on. It was not a very good one, was it? So if we see, there definitely will be an angle of rotation that's going to keep that figure on top of itself. Now here's one of the tricky parts. So if I start here, notice how my patty paper is horizontal perfectly. So if I go 90 degrees, okay, I did my figure land on top of itself. Oof, it didn't. Okay, so I actually need to go a little bit more. So see how this is now slanted a little bit. So I need to figure out, well, how many degrees is that? How many degrees from here to there? Let's think about, let's say I start right here at this point. We'll put a little arrow there. If I rotate it, now I've landed. So my beginning point that was up there is now down here, and I've moved. And if I keep doing that, how many times do I have to go? So there's number 2. See how now my point that started up here is now down here. And we're going to do it again. So interestingly enough, I had to go 3 times. Do you see that? I had to go 1, 2, down to there, and then 3. I had to do 3 times before that point got back to itself. So I had to go 1, 2, 3. Now, if I go all the way around, and this point went all the way around, how many degrees would that be? So that would be 360 degrees in the total circle. And I went 3 times. So is there a way that I could figure out just what 1 turn would be? If I went 3 turns in total of 360 degrees, could I find out what I would do for 1 turn? And that same logic, I'm not going to give you the answer, the same logic would apply here, right? Or even with our square. Although the square might be nice if we're thinking, okay, so that might just be perfectly 90, right? This was vertical, and now it's become horizontal down here. Okay, so then let's think about with our pentagon here again. We've got the same thing. If this is where I start right there, and I go 1, 2, 3, 4, 5. So in this, I had to go this whole circle here, and I had to turn 5 degrees, right? Essentially, this is my center rotation. I had to go this degree 5 times. Could I figure out what just one of these angles is? So that's something you're going to want to keep track of here. Okay? The diagonals, remember, are connecting non-adjacent vertices. So notice that vertex is adjacent to that one. It's next to it. So all of those are next to each other. So that one's actually not going to have any diagonals. We know about the square and the pentagon here. So notice those 2 corners are next to each other, so that we're not going to connect them. But these 2 have this corner in between, so we can connect those and make a diagonal and connect those. So notice this guy, these 2 can be connected because there's that in between them. Those can be connected, and this one. So you'll want to go through and keep track of your diagonals. Once you finish all this, I want you to see if there's a pattern. Your homework's going to ask you to see, what if I gave you a 12-sided figure down here? So if I came down to the bottom, and what if I said it has 12 sides? Could you tell me how many lines of reflection? Could you tell me the amount that's going to be rotated? Does that make sense? So then you're going to want to look at, well, what if I just gave you n? I just said n number of sides. Could you tell me how many lines of symmetry I would see and what the degrees of rotation would be to get that figure to land on top of itself? So this might be something you want to add. You're going to see this in your homework, okay? The solution to all of this. So I want you to look for patterns that you see in trying to figure this out.